So this week is week 13. So in this week, I will teach you on the probability. So we start the basic concept of probability. So I start with the probability of events. So the probability of events can be defined as probability is a type of ratio. Where we compare how many times an outcome can occur compared to all possible outcomes. So by formula, so probability can be written as, so I just put P is refer to probability is equal to the number of outcomes divided by the number of possible outcomes. So one simple example of probability is that, let's say I take some case of an experiment. So in probability we need to have an experiment. So example here is an experiment, experiments of tossing a coin, tossing a dice. So when you toss a dice, there is a possible outcome here. So I put here as a sample space. The possible outcome of tossing a dice is you can either get number 1, number 2, number 3, number 4, number 5, and 6. Because of, if you refer to dice they have 6 numbers. So let's say here I have a dice here. So dice consists of 6 numbers. So 1, 2, 3, and so on and so forth. Consider 1, 2, 3, 4, 5, and 6. So probability of getting number 1. So probability of getting number 1. So just put here probability of getting number 1 is equal to, so there is 1, there is only one, so number of 1, number of getting 1 divided by ns. So n here is equal to numbers, ns. So number of, there are only one divided by, and s here is number of s here is equal to 6. So this is equal to 1 over 6. 1 over 6. So let's say I want to find the probability of getting an odd number. So for this case, this is odd number 1, 3, and 5. So probability of getting an odd number, probability of getting an odd number is equal to probability of odd divided by, or you can say here n odd, number of odd, divided by ns. So we get, there are 3 odd numbers, 3 over s is equal to 6, or 3 over 6 or equal to 1 over 2. This is how we solve the problem here. Now let's say I have an experiment, one more experiment as example 2. So let's say I have an experiment of tossing a coin, tossing a dice, tossing a coin 3 times. 3 times. Now the possible outcome is a coin here we have, if you refer to coin, we have a coin, we have head and the other side is tail. Head and tail. Coin we have head and tail. So if I toss the first toss, I can get either head or tail. These are first experiment, first tossing. First tossing. It's not first one. And the second toss is you can either get, if you get a hit here, you can either get a hit or you can get a tail for the second toss. This is a second toss. And here, if you get a tail here in the first toss, you can either get a head or tail in the second toss. And for the third toss, you can either get a head here or tail. Here you can get either head or tail. This part you can get either head or tail. And here you can get a head or tail. So the possible outcome here is head in the first toss, head in the second toss, and head in the third toss. That's one. Then the second one is a head in the first toss, head in the second toss, and tail in the third toss. So then we have H, T, H. Here we have head, T, T, and here is a T, T, H, H. So then here is T, H, T. This part is T, T, H. And here is T, T, and T. So the possible outcome for tossing a coin 3 times. So we can put this way. So I can put this simple space here is equal to, you can either get 8, 8, or 8, or you can get 8, 8, tail, or you can get 8, tail, and 8, or you can get 8, tail, and tail, or you can also get 8, tail, and tail, and you can get tail, 8, and 8. Then the other part is you can get tail, 8, and tail. Then you can get tail, tail, and 8. Or you can also get tail, tail, and 8. And the last one is you get tail for the first toss, second toss tail, and the third toss tail. These are possible outcome of the possible outcome of tossing a coin 3 times. This is the possible outcome of tossing a coin 3 times. Okay. This is the possible. So NS here, the number of outcome here, the number of possible outcome here of tossing a toss 3 times is equal to 6. So I want to find, let's say I want to find what is the probability. Let's say I want to find what is the probability of getting hit in the first toss, in the first toss of tossing tossing a coin, of a first toss of tossing a coin 3 times. So getting a hit in the first toss is this one. One, hit here, hit, and hit here. There are 1, 2, 3, 4, and 5. These are so probability of getting hit in the first toss. In the first toss, 8 in the first toss equal to number of hit in first toss divided by number of possible outcome. So this will give me the answer of, so number of hit in first toss is 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 5 over 2, 4, 6, 2, 2, 4, 6, 8, and 10. So here is an S is equal to. So here we counted twice. So here we did not have here this one. Because here we counted twice. Here also we do not have T. So this is wrong. So 1, 2, 3, 4, 5, 6, 7, and 8. So NS is equal to 8 here. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So getting a hit here is 1, 2, 3, and 4. So 4 over 8. Or is equal to 1 over 2. So these are the probability of getting a toss. So this is a possible outcome here. So 1 1 over 2. So another question is, what is the probability of getting so the second question is, find the probability of getting hit in first toss and hit in the second toss. Okay. So hit in the first toss, so probability of getting hit in the first toss and hit in the second toss. So probability of hit and hit in the first and second toss is this one, and this one. Okay. So here and this one. So this one cannot be, because of this is head and tail. It's head and tail. So this thing and this thing. So here is NH divided by NS. So the number of H and H is equal to 2 over 8 or is equal to 1 over 4. So this is how we solve the problem here. Okay. So another example, let's say I have an experiment here, tossing a dice. Experiment of tossing a dice twice. Example 3, tossing a dice twice. So the possible outcome for tossing a dice for the first toss is, you can get 1, 2, 3, 4, 5, and 6. Okay. Here's a first outcome, the first possible outcome, first toss. And the second toss is, you can get from here, if I get number 1 in the first toss, I can possibly get number 1 in the second toss, or number 2, or number 3, or number 4, or number 5, or number 6. And if I get in the first toss, I get number 2, the possible outcome here is I can get number 1 in the second toss, number 2 in the second toss, number 3, number 4, number 5, and number 6. And this also happen the same thing. So you can get here. So the possible outcome here, if you write a possible outcome here, the possible outcome here is 6 raised 2 is equal to 36. Okay. So in other words, we have NS is equal to 36 because of we have 6 possible outcomes, and the experiment is we have two outcomes here. The experiment of tossing dice twice is 2 here, so 6 raised 2 is 36. So NS here is equal to 36. So my question is, what is the probability of getting number 1 in the first toss? Number 1. So probability of getting number 1 in the first toss. So number 1 is the first toss is this one. This one, because of if right here you get is 1 and 1, is 1 and 2, is 1 and 3, is 1 and 4, is 1 and 5, and here is 1 and 6. So there are, if I want to find the probability of getting number 1 in the first choice. So there are 1, 2, 3, 4, 5, 6. 6 over, so n1 divided by ns, and s is equal to 6 over 36, or equal to 1 over 6. Okay, another example is, now what is the probability? What is the probability to choose two red cards? Two red cards in a deck of cards. So if you refer to cards here, a deck of cards, a deck of cards consists of 52 cards. So a deck of cards, a card consists of red and black, red and black, red and black color, red and black color, red and black color. So there are 52, there are 26 red and 26 black. So you just imagine the card, okay. So first one is we have diamond. So here is number 1, example. Then we have you have heart. There's a heart. Here is a heart, and then you have a diamond. 1. Then you have a club. A club is like this. The club is like this. It's a club number 1. And then you have the spade. Spade is like this. Spade is like this. This spade. So there is number 1 up to number 10. Then you have J, K, Q. J, K, Q. J, Q, K. J, Q, K. J, Q, K. Okay. And this card, you have this, there are 2 groups here. We have, first one is a red color, and the other card, the other group is a black color. The same thing here. It's a black color. So we have a black color here, 26 red color and 26 black color. Black color is from number 1 up to number 10, and then we have J, Q, K. Okay, we have 26. So I want to find the probability of getting 2 red cards and deck of cards. So the first one, probability of red is equal to, there are 26 red, 26 over, or you can put here is a probability of red, P red equal to N red over NS. So number of red here is 26 over 52. So now probability of getting red is 26 over 2. So once you get the red here, so let's say I have a card here, the possible outcome here. So the question here is in a deck of a cards. So in the deck of cards we have 52 cards, and there are 26 reds and 26 blacks. So to get two red cards, the first red card is, the possibility of getting first red card is 26 over 52. This is the probability of getting red card. Then probability of getting red card, given we get the red card before that, is equal to, so the first one we get 26 over 52. Now the remaining is, once we get the card here, if you do not return a deck there, the remaining of card here is 51. And the remaining of, once we get a red card here and we do not return back to the deck of cards, the remaining here is 25. So that's why we have 26 over 52 multiplied by 25 over 51. For to get a red card and deck of card without replacing it is, the first one is 26 over 52, and the second one is, because of we get a first red here, so we do not replace in the deck of cards, so the remaining there is 25 reds, and the remaining of the total number there is 51. So 26 over 52 multiplied by 25 over 51, or equal to half multiplied by 25 over 51. So it's equal to 25 over 51. So the answer is 25 over 102. This is the answer for getting two red cards in the deck of cards. Then this is the first case. This is a card without the card, choosing a card. So this is a case of choosing a card without replacement. Now what if I choose a card with a replacement? Choose a card with replacement. Now so just now is choosing a card without replacement. Then the second case is choose a card with a replacement. So the possibility of getting a red card in the first selection from a deck of cards is, there are 26 red cards. Probability of getting red card for the first selection is there are 26 red cards over 52 cards overall. So 26 over 52. Now the probability of getting two red cards. So two red cards, first selection is red and the second selection is red, is equal to number of red for first selection and number of red for the second selection divided by n. So this can be written as probability of red in the first selection multiplied by probability of red in the second selection. So if I select a card there, select card from deck of cards, then I replace it. Meaning to say we return to the deck. So the first one, the probability of getting red card is 26 over 52. Then if I replace the card in the deck of cards, so the number of cards here remaining 26, remaining 52, the number is remaining 52. Then the possibility of getting red is also 26, because once I get the card and then replace it back. So here is 26 over 52. Then the second round is also 26 over 52. Or in other words, it's a half multiplied by half is equal to 1 over 4. This is to choose a card with a replacement. Okay? Or selecting a card with replacement. This is a case of. Just now I explained to you is we select a card without replacement. Once you get a card, in the first case, you get the answer here is 26 over 52 multiplied by 25 over 51. Because of we get a card, we get a red card, and without replace it, the balance there is 51, and the balance of red card is 25. So the first case is property of R and R. Property of R and R is equal to 26 over 52 multiplied by 25 over 51. Whereas for the first case, you select a card and you replace it. First selection, you get 26 over 52. Then you replace it. Then the number of cards is the same number of cards. So still 26 over 52 is equal to 1 over 2 multiplied by 2 is equal to 1 over 4. This is how we solve the problem there. Okay. Now this is a basic the foundation part of the probability events. So then we go to the next part is probability of mutually exclusive event. Probability of mutually exclusive. So the mutually exclusive event by definition is two events cannot occur together. Two events cannot occur together, and then the event is to be mutually exclusive. When the two events cannot occur together, then the event is to be mutually exclusive. Okay, so the definition here is the definition by definition. Two events are said to be two events are said to be mutually exclusive if they cannot happen or cannot occur at the same time, or cannot occur together at the same time or cannot occur together. Okay. They cannot occur together or it cannot happen at the same time. Right? So by diagram, if I draw a Venn diagram here, so if I have two events A and B, and here is S, and this is said to be mutually exclusive event. Mutually exclusive event. And if I have here, I have, let's say here is a simple space, and here is event A and event B. There is overlapping here. So here is A and B. This is known as a non-mutually exclusive event. Because of this thing, they can occur together. These things, they cannot occur together. So this is a non-mutually exclusive event, and here is a mutually exclusive event. So therefore, the mutually exclusive event, they cannot occur together. So let's say we take one example here. Tossing a dice. Tossing, example of tossing a dice. Example, tossing a dice. Then the possible outcome here is possible outcome here is tossing a dice is number 1, number 2, number 3, number 4, number 5, and number 6. And in other words, you can put here is an S is equal to 6. Number of possible outcomes is equal to 6. So let's say I want to find tossing a dice showing a number, showing when the result is showing a 2 or 5, a 2 or 5, showing a 2 or 5. So I want to find the probability of 2 or 5. So 2 and 5, they cannot occur together because of if 2 occur, 5 cannot occur. If 1 occur, 2 cannot occur. So to get 2 or 5, so we can find the probability of 2, or means plus probability of 5. 2 or 5 cannot occur together. So P2 is equal to probability of getting 2 is N2 over Ns plus by P5 is N5 over Ns. N5 over is N5 by probably here N5 over Ns. So this is equal to probability of N2 is only 1 2 is 1 over 6 plus by only 1 5 is 1 over 6 is equal to 2 over 6 or 1 over 3. This is how we solve of getting 2 or 5. Because of this is a case of mutually exclusive. Because of 2 and 5 cannot occur together. So once 2 occur, it's nothing to do with 5. So this is known as a mutually exclusive. Okay, now I'll give a last example here for the mutually exclusive. Let's say this is just now is a mutually exclusive. Here is I want to show you an example of non-mutually exclusive. Let's say a box contains of box contain of 3 yellows, a box contains of a card, a card of a black color. So this card is a card of black color, number 1, a card of number 2, a card of number 3, and a card of number 4. So let's say I have here experiment here. A box here contain of a card, a red card and blue card, red and blue card. So there are red card with number 1. Let's say I put here is this symbol is a red card, red card, and this symbol is, let's say this is a symbol of a blue card. Say blue card. So I have 3 red card with number 1, number 2, and number 3. And I have 2 blue card with number 1 and number 2. Okay. So I want to find the property of getting a red card and number 3. Red card. I want to find the probability of selecting a red card and or drawing or selecting number 3. So there are you can draw a Venn diagram here. You can have a Venn diagram here. This is, let's say a red card here is A here, and selecting number 3 is B. Let's see, for example, here is A and B. A red card is A and selecting 3 is B. So if I draw a Venn diagram here, so I have a red card. I have here a red card. I have 3 red cards. Okay, I have 3 red cards. So I have 3 red cards. And then I have selecting number 3. I have number 3 here. So here is A and B is a red card. So I have a red card here. B is number 3. So here is red card is I have 3 red cards. 1, 2, and 3. And selecting number 3, I have only 1 3. Like this. B is number 3. So B is number 3. There is a B here, intersection here. So B here is belong to number 3 here. It's a red color is belong to B, and number 3 a red card is belong to A. So these are how we draw the Venn diagram here, and the rest here is 1 and 2. Okay. So NS here, the number of space here is equal to 5, because we have 5 here. Then getting a red card, so probability of A is getting a red card, probability of A, probability of getting a red card, probability of getting red, or number 3 can be written as probability of red plus by probability of 3. Red or 3 is probability of R plus by probability of 3. This is a case of the mutually exclusive. This is a case of if we put like this formula here, this is a case of mutually exclusive. But in our case here, this case is a non-mutually exclusive event because of red card and number 3 can occur together. Here is a red card, the square here is red card and the number 3 can occur together. So this is a non-mutually exclusive event. So probability of red card or number 3 is equal to probability of red card or number 3 PR plus by P3. This is a case of mutually exclusive. But in our case here, we are referring to non-mutually exclusive. For the non-mutually exclusive, and this one must be solved like this. Probability of red or number 3 is equal to probability of red plus by probability of 3 minus by probability of red and 3. So this is equal to, now probability of red, we have 3 red, 3 over 5, plus by probability of 3, we have only 1 3, 1 over 3, 1 over 5, and minus by probability of red and 3, we have probability red and 3 here is 1 over, also 1 over 5. So 1 over 5. So 3 over 5 plus by 1 over 5 minus by 1 over 5 is equal to 3 over 5. That's why if you refer to this graph, so the possibility of getting red and number 3 is span. So 3 over 5. This is how we solve the problem here. Now, let's say I want to find here, for the case of non-exclusive event, I want to find what is the probability of, here is this is a red, and this symbol is a blue card, blue and red. So I want to find what is the probability of getting the probability of getting blue, and number 2. So blue and number 2. So if I have here blue and number 2, blue or number 2, blue or 2. So blue here is referred to, let's say this is a event and 2 is a B. So if you draw a curve here, draw a Venn diagram here, it's a Venn diagram. So A is a blue, let's say A here is a blue, and B is number 2. So I have blue here. Here I have blue. Blue is I have blue here is 1 and number 2. Okay. Here is blue. Blue is I have number 1 and number 2, blue. Then I have a blue there. Blue is, the other blue is the red blue. Number 2. B is number 2. We have 2 twos. 2 twos. B we have 2 twos. 2 is a red color and 2 is a blue color. So the other one is 2 and 2. There is 2. Here is A and B. We have one is 2 for the red color and 2 for the blue color. So there is an intersection here. So this is B. Okay. So getting a red or blue, so probability of getting a blue and number 2 is equal to probability of blue plus by probability of getting blue or 2 is equal to probability of blue plus by probability of 2 minus by probability of blue and 2. Probability of blue minus by probability of blue and 2 intersect blue and 2. So for this case, probability of blue, say probability of blue is so sorry, this one can be written as, because of this is can be written as probability of blue is PA is a blue plus by probability of 2 is PB minus by probability of B intersect 2 is a probability of A intersect B. Okay, so this will give me the answer of PA. PA is the property here is the rest is outside here. So sorry, the rest is 1 2 1 2. Here is 1 and 3. 1 and 3 there. So here is S. Right? So probability of A here is 2 over 5. So here is equal to 2 over 5 plus by probability of B. Probability of B is equal to B. I have only probability of B is number 2. Number 2 we have also 2 over 5. 2 over 5. Minus by probability of A and B. Probability of A and B is 1 over 5. That's why we get 4 over 5 minus by 1 over 5 is 3 over 5. Okay? So here is 3 over 5. So I have 1, 2, 3, 3 over 5. Getting blue and blue or number 2 is 3 over 5. This is how we solve the case of Mercalli. So I have 2 examples here. You can solve this one. Let's say I have here exercise here. Let's say I have exercise here, exercise. So a shilling, a coin is tossed 3 times. Okay, is tossed 3 times. Is tossed. The coin has been tossed. 3 times. Okay. Question is, write the sample space of S, and B, what is the probability of getting? What is the probability of getting hit in the second toss, in the second toss, and tail in a third toss. So these are here. Okay. The second example here is 1. Number 2. From a deck of cards, from a deck of cards, A, what is the probability of drawing a heart and a black card? What is the probability of drawing a heart and a black card? A heart and a black card. B, what is the probability? What is the probability of drawing a heart, and a heart or a black card. So I have two questions here. Okay, I have two questions here. So please do it individually. And please submit to me before the today is 21st. You will have to submit to me before 28th of July. This assignment. So please submit to this individual assignment. Okay. Now please send to me before. Please submit before. 26th of July. 26th of July. Okay, that's all for today, and this is the last topic of our lesson. So on property, the basic concept of property. We have learned about the property events and mutually exclusive event. The other one is a non-mutually exclusive event. That's all. Thank you very much.